Welcome back to the third part of our shoot today. Today's topic has been saddle trees and what is on the inside of our saddles. And I get many questions from my customers about this topic now, and there are many myths surrounding it. And that is, what material should I choose for my saddle tree? Wood, a synthetic material, or carbon? These are the most common materials used. And I'll just walk you through it. This is a wooden tree by a very well-known German manufacturer. It's a Passier tree, and it's wood covered with leather at the top, and at the bottom we have glued beech wood, a seat rail, and this is a very finely crafted masterpiece. Clearly, there are many steps involved in the process of making such a piece, because obviously we want it to be flexible, also flexible around the axis, and wood is a great material to achieve that. And this is basically the foundations of making saddle trees. And this technique has been around for many years, and in the 1950s, 60s, 70s, it has been perfected by this manufacturer and many other manufacturers in England, France, Germany. And we ended up with saddle trees that have great properties for the rider. So you shift the weight a little bit and the horse immediately receives an aid, and that is great. The steps involved in making such a piece, gluing, pasting, screwing, there are so many steps involved. And that is, well, a great craft, really. If you want to complain, you can say craft means you're not using machines, and people, obviously, they are flawed sometimes. So let's say you start a piece like that and you're in a bad mood because it's Monday or whatever, and you start making this piece a slight bit different than you would usually do it, and there's a deviation of a few millimeters. This will actually affect the entire piece, and it will be a bit different, and obviously that's a part of the charm of the craft. But if I want a product that can be duplicated, where the properties are precise and actually the same for every product, then obviously the craft has limits. But this structure has been around for many years, and it has worked well and hasn't really been changed since the middle of the last century. If you want to attach the girth, there is a nylon part that's laid across the saddle tree, pressing it down. Here in the front, you can attach the front girth strip. There is a hole for it, for a dressage saddle, for example. And the traditional girth is across the tree. So this is it for the wood. Moving on to the synthetic materials, plastic, that has been around since the 70s, 80s. And like many new things, it was off to a bit of a rough start, because the plastics that were used in the 70s and 80s can't be compared to the ones we're using today. There are so many different polymers today. We have pure forms, blended forms, and it's all poured. That makes a huge difference in production, makes it faster, makes it cheaper, and makes it more precise. And when we started working with plastic, the materials, they just can't be compared to what we have today. So in terms of thermosensitivity, for example, if you would leave one of these old saddle trees at the front of your truck, then it would become soft, because in there it had 60, 70 degrees Celsius, or in the winter when it was cold, it would become brittle. And this bad reputation affects the synthetic trees until today. People say it breaks easily, it changes the shape when it gets hot or cold. And every material, when I adjust it or make amends to it, when I bend it, it likes to go back into the shape it was before, and plastics like to do that way more than steel, for example. And the simple plastics that were used at the time, they had exactly that problem. So you use heat to adjust the size, as I showed you in the video before, but then it would just go back into its original shape. And that obviously is a problem, but today we do not have that problem anymore, as the materials we're using are very precise and they went through many stages of development. So today we have a product, in this case this is the D2 tree by Prestige, and the product has evolved so much the manufacturer can offer a lifelong warranty on this. Wooden saddle trees are usually 5 to 10 years warranty. And this really shows the level of quality these trees have reached. You can see a few holes along the sides. This is where we attach the girths. And if I have fitted the saddle and then there is a problem because it is sliding forwards or backwards, in theory I could make amends afterwards. I could find new points to adjust, to attach the panel or the girth. I can't do that in a wooden tree. But here I can make many adjustments and the material is sturdy enough that I can put a screw in it. And this is very helpful. Here the front is as stable as a gullet plate would be. Very solid plastic. It comes in different lengths. The shorter the ends are, the better for the horse, but the less stable you'll sit in it. So you have to find a compromise between the needs of the horse and the needs of the rider. But as I said, synthetic materials have a bad reputation because a few manufacturers started selling these very early on, and the materials that were used at the time when they got older or were exposed to higher or lower temperatures, well, they changed the shape or they broke. And this affects the reputation of plastic trees up until today. So people say no to them and they go back to what they know, to the traditional option, and that is the wooden tree that has been around for hundreds of years and has satisfied customers for a long time. And this is newer, but the technical possibilities are equal. At most, in many instances, actually it is superior to the wooden option, and it is as flexible as the wood. Also, it is super lightweight, and these are very great materials that we're working with today, and the lifelong warranty also is a huge selling point. So this is a synthetic tree and it works just as well. Then I have a third option. I don't have that right here, but it looks exactly the same as this one, and that's carbon. Carbon is super lightweight. Carbon is sexy. It comes from racing, car racing, sailing. All these high-tech sailing boats are almost made entirely from carbon, and it's a very exciting material. I'm a fan and I've experimented with it and we've used it in a few areas, but I think it's not appropriate to make an entire saddle tree out of it because it is very stiff. It's like glass. If you drop it, it will burst into 1,000 pieces, and it is very sturdy but so stiff. It has many great properties, but because it's so stiff and it can't deal with any bouncing movements, I do not think it's a great material for a saddle tree. And the manufacturers working with it are learning that the hard way right now, and I think it will be a while until we can use it long term to make saddles. Because I think it is a great material, and I'm convinced that over the next few years we will do a lot more research into it, and there's some very interesting ideas from aeronautical engineering. The wings of airplanes, for example, they are using connecting elements to make it more flexible, but it will take a while until we can apply that to the making of saddle trees. So because it's so stiff at the moment, it breaks a lot because, well, I as a rider also want to feel the movements of the horse, and I want the horse to feel my movements, and carbon doesn't allow that. So, conclusion, these are the three main materials used for saddle trees: carbon, synthetic material, plastic, and wood. And they've all been around for longer periods of time on the market. And if I could choose between all of them, and I do not have a priority because the horse needs something specific and I'm not limited by my riding skills, then I would choose the plastic because I have a very clear product description and I can adjust it much better. And also the lifelong warranty does convince me. And I like that it is very light. So I just want to say again, the times where just one option was right and the other was wrong, these are over.